which doesn't get read much because it's very mathematical. But this whole thing is a measurement theory. All of this is quantum mechanical. In the very last step, when you can read either this spot or this spot, we are tongue-tied. We don't know what to say. It's a big problem. Physicists are very proud that they know from A to Z. Well, here, suddenly, we don't know Z. All right? So that is a problem. So that's called, let me call it the readout problem rather than measurement. To say it again, a single atom, you make that measurement. If you repeat it many times, you get the quantum mechanically predicted probabilities. No problem. Quantum mechanics works statistically. It works just perfectly. But one measurement gives you one spot, up or down. In either case, how does one describe the last step? That you go from the quantum state, which I call the entangled state, to a single blob that one can see. So you say, well, we have the same problem with the classical coin, right? You toss that coin, you go up in the air, it's spinning, it's pointing in some direction. When it comes down, it got to flop, and we don't know how. But classically, you have an out. You say, Newtonian mechanics tells me that I know exactly how, if I know the initial conditions, it will be up or it will be down. It's only because that you don't know the initial conditions. So we are happy. We say, well, it's because, it depends on initial condition. We don't know it, but nobody ever cares about. But nowadays, people do care about this, so they study how it depends on initial conditions. So that's why you sometimes get chaotic motions, so-called. Sometimes you don't. Sometimes you really can. It's easy to predict. Sometimes it's hard to predict. But it is not saying that you cannot predict. In quantum mechanics, you cannot predict. It really is 50% chance of up and down. You see the dilemma there. So that's why in quantum mechanics, that is a problem. In classical mechanics, we think there is no problem. Maybe we didn't push people hard enough. Before quantum mechanics, there's no problem. Suddenly, now we have a problem. Now, how do you define this problem? It's a horrible problem, or it's a really interesting problem. Is it physics, or it's a philosophy? Wow, if it's philosophy, all possibilities happen. All right? So you say, well, but all I need is another bigger machine. But then if you say that, you say, oh, well, bigger machine. Well, the thing is that you can just keep doing this with then two more possibilities, okay? So you say, well, that's quantum mechanical. The screen is quantum mechanical. So I put two more things. Well, then you say that's quantum mechanical. Then you just keep doing it. That's called the von Neumann chain. So the problem is always there. So we call that the interpretation of quantum mechanics. We don't know how to solve it as physics problems, so we just interpret. It's like fortune telling. It's an oracle. We're going to interpret what's going on. It's philosophy. Well, the trouble with philosophy is that it's fertile ground for charlatans and false prophets. So let me just tell you a little bit about this interpretation of quantum mechanics. First of all, there's a theory. That is the one I'm telling you about in the 60s. At that time, this guy was a graduate student. He says, well, that's very simple, you see. There's no dilemma. I have these two paths. If I go on this path, I will see the spot here. If the electron go on that path, I will see that spot there. So why? So the theory is that, hey, instantly the universe split into two. In this universe, you live here, so you see that spot. But your evil twin in the other universe will see that. They shall never meet. So what's the problem? There's no problem. The other one here is the one, consciousness. It's an interesting one. And this book discusses it. And they actually kind of believe it. I mean, it's okay to try it because we don't really know what consciousness. So now you can see, you can think it's crazy. I called it wild, but I didn't say it's wrong. You can't prove it, it's wrong. If you want to involve psychology or philosophy, that's fine. But I recommend this book because it describes the steps that I was telling you, much richer, of course, in the whole book. And it's a very easy book to read. I recommend it. There's all the steps before until you worry about this readout problem of the consciousness problem. Now, I thought this one, I cannot give it to any other audience except an audience that are bilingual. There was a high energy theorist. He says, there's a Tao of physics. He says, well, in Chinese, the ancient Chinese mystics, like the Tao people. Actually, the Tao people are not mystics, not completely anyway. They're very practical also, for what little I know. He said, well, to the Chinese mystic, of course, the rule of matters is the same as no rules. Okay?